Okay, you're being tasked with making some simple calculations in the spreadsheet. If you've moved the data you collected in lab into the document shared with you in Doctopus, then you're ready to go. I've entered just some sample data, just a few heights in centimeters to the closest 0.5 centimeter. That might resemble what you collected. I've got a group of 13 people's data, both for height and for foot length in centimeters to the closest millimeter, 0.1 centimeters. So we're ready to make some calculations. You can do this anywhere on the spreadsheet. If we want to calculate a mean or average height, maybe into this box. There's a few ways to go about this. First, I can do it the long way. I could just go to Insert and choose the sigma symbol for function. I'm going to insert a function into that cell. And specifically, I want to navigate to a statistical function, and then I want to choose average. That's going to help me calculate the average or mean of this data set. So you can see now in this cell, the value in this cell will equal the average of whatever cells you'd like. So I'm going to choose from B, column B, row 2, down to column B, row 14. That's the data I want the average of. So now you can see what's in this cell will equal the average of cells B2 to B14, or B2 colon 14. That's going to give me this whole row. So if I hit enter here, it'll calculate my mean. Looks like 159.2 centimeters. That's great. Now, a quicker way to do that, if I want to calculate the mean here for my foot length, would be I could just go to this bar and to the sigma symbol, click signal. I've used average recently, so it's going to be here. I could just insert a function by going to the sigma, average, do it the same way. But I can skip both of those steps if I know the formula I need. And for this case, I can just type equal sign, because I want this cell to equal. And I can just start typing average, and that's the one I want. And for what cells? Again, just select the cells you'd like. Double check C2 to C14, that looks correct, so hit enter. And I've just calculated the average of C2 down to C14. So our average foot size is 23.9 centimeters. I can do the same thing here for standard deviation. So I can insert a function. Again, it's a statistical function. And I can scroll to standard deviation. And I want to select the values I want the standard deviation. Same data set, B2, B14. Enter, we'll calculate it for you. So my standard deviation is 22 centimeters. That means that the majority, we would expect, if this is normally distributed data, we'd expect about 68% of those values fall 22 centimeters, or one standard deviation of the mean. So if our mean height is 159.2, we'd expect 68% of that data to be plus or minus 22 centimeters from our mean. Likewise, for standard deviation, I can calculate that the same way, inserting a function, or now I know what I'm doing, I can just type enter. Or equal, sorry, I want this cell to equal. It's predicting what I want to do here, but I can start typing standard deviation. It's even predicting what cells I want to calculate. And I've calculated the standard deviation of all our foot lengths as 3.3. So the majority, 68%, in normally distributed data, 68% of these values would fall within 3.3 centimeters of our mean foot size of 23.9.